My name's David Lloyd, and I'm an account executive at Grey Matter. For those of you not familiar with Grey Matter, we're based in the sunny southwest in Devon, in a little town called Ashburton, and we've been trading since 1983. We provide software services, mobile and licensing advice for over 400 publisher partners. We cover security, design and media, cloud, DevOps, network tools, and more to all company sizes and verticals. We're proud to be a Condusiv partner. We've been working with them for many years as their products enable us to give real-world performance gains to customers and extend the life of their hardware investments. We're hosting this webinar as we want to help you cut costs and improve your SQL performance by using DiskKeeper and V-Locity from Condusiv. As a thank you for attending, Condusiv will provide you with a fully featured copy of DiskKeeper Server so that after the webinar you can start to experience the tool for yourself and get a feel for how it works. And that will be sent via a link in an email from Condusiv. If you have any questions during the webinar, please use the question feature and we'll answer them at the end or take them offline if they can't be covered in the time we have. Now I'll hand you over to Spencer Allingham. He's the Technical Director at Condusiv in the UK, and he'll show you how their IO reduction software can help your business. Okay, so yeah, we are Condusiv. We have been around for pretty much almost as long as the guys at Grey Matter have, about 30 odd years, originally producing software to enhance the performance of VAX VMS systems, which I'm sure you're all far too young to remember. But we have the DiskKeeper brand, which a lot of you may remember as being a go-to solution for disk fragmentation back in the day. It's really not about fragmentation anymore and defrag. The product has evolved significantly, and I'll take you into a little bit of a technical deep dive and explain why, and more importantly, why you should really be installing it on those SQL servers to get additional performance gain and things like faster SQL transactions and more SQL transactions done per minute, per hour, per day, and so on. So we'll talk about the technically how it works in just a moment. About 4 years ago now, Gartner gave us the cool vendor badge that you can see here. Really for what we were doing for things like SQL and other storage hungry applications like file and print servers, SharePoint, business information systems like IBM Cognos, or really what we were doing to help the performance of those in the virtualized arena. And probably more importantly for you guys that care more about SQL, just down here, I think it was late November of last year, we actually achieved certification from Microsoft themselves for running DiskKeeper's sister product V-Locity in the Microsoft Azure cloud using SQL 2016. And the great thing about that was, yes, we were able to jump through all of the hoops required to get the certification from Microsoft. But during the tests that we ran, we were actually also able to show that they were able to get 28% more transactions done in the same amount of time from that same SQL instance when our software was active. Now, the type of workload they were running in that particular environment was an online transaction processing type workload. So these 28% additional SQL transactions directly equated into 28% more orders being able to be processed by that particular SQL instance. So we were very, very pleased to get that. And I think even now we're still the only software-only vendor to have achieved that certification from Microsoft. The other guys who have got it are more storage hardware related. So anyway, that's probably enough about us. Let's
get down into the weeds and talk technically why it's a good idea to remove some of the inefficiencies that can really slow things like SQL Server down unnecessarily. In fact, this is one of the questions that we asked during a survey at the front end of 2017, and we're going to be doing a new one very shortly, so keep an eye out for that. But in that survey, one of the key questions that we asked was this: regarding your IO intensive applications running on Microsoft SQL, do you experience staff or customer complaints due to sluggish performance? Now, thankfully, most of the respondents said, no, actually, we don't get complaints about performance. It's running pretty well. But 27% of the respondents, so almost a third, said, actually, yes, we do. We suffer performance issues and we get complaints about it. And that is something that I hear quite a lot when I'm talking to customers. And it's definitely something that we can help with. We can help remove these inefficiencies and really allow SQL to fly and really give you all of the compute that you've paid for when buying that hardware infrastructure to run the instances of SQL in. And I'm guessing that, yes, we can definitely help these people that responded yes, but even a lot of these people that said, no, we're not getting complaints, would probably still like to have those SQL instances run faster and be able to do more with them in the same amount of time. So let's talk about why these things can start to slow down. Now, of course, in some cases, and I'm sure this isn't for you guys listening, but in some cases, SQL queries can be badly written. SQL tables can be maybe not created in maybe the optimum way. I'm trying to be diplomatic, of course, but there is an underlying issue that's really to do with the Windows operating system and the way that it interfaces with whatever type of storage is attached. And that also has an impact. And it's something that can be very easily remedied and corrected with the use of our software. So what we have here, by means of explanation, is a rough representation of a virtual environment. Now, keep in mind that our technology works just as well in a physical environment as well. But in this case, we've got a virtual environment. So we have sitting here in the middle, either a Hyper-V physical host server, or maybe it's a VMware ESXi server, and you're running a number of guest Windows operating systems in these virtual machines, and some of these may be running instances of SQL. You might have a file and print server, maybe some application servers. The point is they're all generating storage IO traffic that's being funneled down through the hypervisor, through that physical host, and then onto the storage at the back end. Now, typically in this type of environment, this storage at the back end would be something like a SAN, a storage area network, maybe even a tiered SAN, where you have a tray of SSDs sitting at the top tier, and then maybe some slightly slower but larger capacity storage underneath that, like 15K SAS drives or the like. This is what it looks like when everything is working well and working efficiently. And by that, what I mean is you have the least number of storage IO packets traveling out to the storage, and each one is carrying a very good payload of data. So you have the least number of IOs carrying the most amount of data. And that is a very efficient way of moving data between server and storage and back again if that data needs to be read later on. It means that the data, when it arrives down here at the storage controller, it gives the storage controller the opportunity to create nice, large, unbroken stripes across its media using the least number of storage level operations. Now, when you're running Windows in these virtual machines to host your applications like SQL, this is not typically what you're actually going to get. What you're going to get will look more like this. Now, what's happening here? As these NTFS file systems, your C drive, D drive, E drive, and so on, as they mature over time as you're creating new files, you're deleting files, you're moving files around, what will happen is the free space on those volumes will become more and more fragmented into smaller and smaller free space extents. And that makes it very difficult for the Windows write driver to store that data effectively. What's happening is the Windows write driver is going to the Windows free space cache. It's finding a free space extent that's not big enough. So it starts writing, finds, I don't have enough room. So I'm going to have to split the write. I'll send the data I have already written on down to the storage. I'll go back to the Windows free space cache, find my next available free space extent, and I'll continue writing there. But it'll find again, I still don't have enough room. So I'm going to have to split the IO again, go back to the Windows free space cache again, find my next available extent, and basically repeat and repeat and repeat until it has been able to complete that write. Now, in the real world, what this means is an average gigabyte of storage IO traffic that should take maybe 2,000 IOs to complete is now taking 30,000 or 40,000 IOs to complete. Each IO that has to be generated takes a measurable amount of time and resource to process. It's a bit like saying, okay, on this side of the room, I have a liter of water, which is my data, and I need to move it to this side of the room, which is where the storage is. It's a hell of a lot more efficient to make one trip across the room with a liter-sized jug than it is to pour that same amount of water into tiny shot glasses and then take the first shot glass across the room and then come back and take the next shot glass across the room and then come back and take the next shot glass across the room. You see how these small shot glass sized IOs make the whole environment work so much harder than it needs to process that same amount of data. And what it means is when this small fractured IO traffic is arriving down here at the bottom at the storage controller, it's arriving in small chunks at a time. The storage controller doesn't understand the relationship between the packets because it's too far abstracted from the top here where that traffic came from. So as far as it's concerned, it's only receiving these small packets of data. It now only has the opportunity to create much smaller stripes across its media. And that means a lot more storage level operations are required to process that same amount of data. This split IO situation adds a performance penalty, which will affect SQL and other applications that might interface with SQL. We call this the Windows IO tax, as in a tax on your performance because you're running Windows and it's not terribly efficient over time in how it interfaces with the storage. Now, if you're running SQL in a virtualized environment, as in this example here, this performance penalty from the split IO situations gets amplified by something called the IO blender effect. And what's happening here is you've got these small fractured IO packets coming from the various virtual machines. They're being funneled down through the hypervisor, which acts like a blender, and it mixes these disparate IO streams around so that what comes out between the physical host and the storage controller is now really a chaotic mess of small, fractured, and now very randomized IO streams. But by the time they hit the storage controller down here, well, they couldn't be less storage friendly. So this is really not a great situation to have, and it will start to affect the performance of these applications that you care about, including SQL, or Maria or whatever database you have running up here. They will start to slow down. And unfortunately, unless you take some corrective action, and that means maintenance time, this situation will tend to get worse over time. It won't stay the same or get better. Now, a lot of database administrators go some way to mitigating this by doing really what is a sensible action, and that is when they format the volumes that are going to be hosting their database data, they format it with a larger cluster size of 64 kilobytes. If they were to leave it at the default 4K cluster size for an NTFS volume, this split IO situation would be immeasurably worse. So that does go some way to mitigating this, but it certainly does not make the problem go away. It certainly does not fix it. So what do we do with our technology today to help solve this? There's two things. Firstly, we add an extra layer of intelligence to the Windows write driver so that when it's writing the data, instead of having to go back to that Windows free space cache to find another free space extent that's not the right size, it says, write driver, start writing here on the NTFS volume where there is a large enough area of free space to put that data into without having to split it up, or split it up the least. And of course, the software can quietly and automatically in the background help to create those nice large areas of free space as well. So that by itself significantly reduces the number of these excess unnecessary storage IO packets that you see here in this example, and it displaces them with the fewer but larger IO packets that are a lot more efficient to travel between server and storage and back again. But we then reduce the IO load on the storage even further by using a RAM caching technique in these guest Windows operating systems, or on Windows Server if it's a physical SQL server. And there we can use some of the idle available RAM to satisfy a good percentage of the read IO traffic so that it doesn't have to hit this lower part of the estate. So that further reduces the IO load that the backend storage has to deal with. And that's really an important thing, because if you think about this as an IT stack, that storage at the back end is always going to be the slowest part of the IT environment. Even if you have a tray of SSDs or an all-flash array on the back end, which are nice and quick and provide plenty of IOPS, RAM is still 10 times faster, roughly, than SSD. So the greater percentage of those reads that you can satisfy from the server-side DRAM, the more that's going to help things like SQL performance. So that's really the main two parts of the technology. Think of it as an IO reduction technology. We're reducing the amount of workload that this slowest part of the estate has to deal with. We're making sure that the workload it does receive down here is optimized so that it can be dealt with in the most performant way possible. And that's really how you can resolve these issues and get back that sort of day one SQL performance and really boost it further with the RAM caching. Now, I know that SQL has its own form of RAM caching or buffering, and it does a reasonable job. I mean, what it's trying to do is stuff as much of its database or databases into whatever available memory is there to try and aid the performance of people interacting with it. But it doesn't do as good a job, if I'm honest, of making good use of that RAM. We have some very intelligent telemetry-based algorithms to figure out what type of data needs to be in our cache and when. So the performance improvements and the gains that we can provide with our software, it's not a replacement to the buffering that you have natively in SQL or in the Windows operating system. We provide these benefits and gains in addition to that caching that's already taking place. And it can be quite significant. I mentioned at the top of this about that testing we did with Microsoft, where they saw 28% more SQL transactions able to be done in the same amount of time. And that's quite conservative, if I'm honest. I've seen a lot better gains than that with real world customers. So just briefly to recap, we have very lightweight software that you can easily install into your environments that provide these large, clean, unbroken writes to give you a greater payload of data with every IO operation, and it also reduces the number of IO operations required. We can cache hot reads from some of the idle available memory that should be sitting there in all of your Windows machines. We have a benefits dashboard that not only shows you how much of that IO traffic we've been able to eliminate, but it also shows you things like how much storage IO time has been saved. And I'll show you an example of that in a sec. Here we go. So this is a typical example of what we would expect to see on average on something like a SQL server. If you can assign just 4 GB of available physical memory for our RAM cache, this is typically what you would see. So on this server, in the last 3 weeks, we eliminated over 9.5 million storage IO packets from actually having to go out and be dealt with by that slower storage at the back end. That represents 64% of all of the read IO traffic not having to go out to that slower storage, and about 30% of all of the writes. And what this meant was they saved over 20 hours of storage IO time. Now, this storage IO time is calculated based on the number of IOs we're able to eliminate, multiplied by the average IO response time at the time those IOs were generated. I hope that makes sense. It's basically an accumulation of all of the time the storage didn't have to spend processing these IOs. I hope I've explained that okay. If there are any questions about that, please feel free to put them into the Q&A box on the side there, and I'll be happy to go through any questions you guys have at the end. No problem at all. So we've spoken already a bit about the write IO reduction, this very thin storage filter driver that can add this extra layer of intelligence to the Windows write driver so that it can make better choices when it's writing. It's important to mention what we're not doing as well. We're not changing or touching the contents of the storage IO packet. We're not trying to do anything clever like compress it or dedupe it on the fly. It is still the standard Windows write driver creating a standard NTFS IO packet and sending it out to the storage. We're not bypassing Windows in any way. And that's important for those of you who want to make sure they stay ACID compliant with their SQL databases. So we're just simply making the Windows write driver able to avoid this situation where they're splitting the data up and sending it out in a very inefficient manner, and we're replacing it with much smaller but larger IO packets that are much easier for your environment to process. In terms of the reads, we have made the software in such a way that it can only use otherwise idle memory. It will not compete for RAM with SQL or anything else that's running. And often I get queries from customers who say, well, you know, my SQL instances, they're chewing through most of the RAM that's available on the system, and we're really not seeing much out of your caching. And the reason is the cache size is too small, or there's not enough memory free for us to even establish a cache in the first place. The solution for that is quite simple and quite easy, and really has kind of become standard practice now. So you guys might already be doing this, and that is to cap the amount of memory that SQL can take for itself. It's quite easy to do. Now a quick Google search will show you how to do it. There's a good write-up on a website by a chap called Pete Bursky on how to do this. If you can cap the amount that SQL can take for itself, still leave it some to cache with or buffer with, don't disable it, but leave us at least, if you can leave 4 gig of available physical memory, that would leave us roughly 2 gig as a cache size. And that's usually enough to eliminate somewhere between 30 and 50% of all of those reads from having to go out to the slower storage on the back end. If you want additional performance, the quickest and simplest and cheapest option is just to give us a little bit more RAM to play with. Let us have a larger cache size, and we can satisfy a greater percentage of those read-heavy workloads at the speed of RAM rather than the speed of the storage underneath. So the solution there with SQL servers is just to take a look at how the RAM is being provisioned, make sure that SQL can't chew through pretty much all of the RAM and leave only a few hundred meg free. if you cap it and leave us enough room to play with, we can show you some very good returns on that investment. So what do typical customers look like? And all of these are full case studies that are available on our website. So if you wanted some light bedtime reading, they're all available to download and read. I won't give you death by PowerPoint by picking out every single one of these, but I'll pick out a couple that I know are SQL related. This one down here on the bottom left is Bell Mobility. They're a telecoms company over in Canada. We used our V-Locity software in their virtual environment to reduce the amount of IO traffic going out to their backend storage by 61%. And that gave them SQL report queries that were 3 times faster. Now, if you think about that in terms of IO headroom that we're handing back, or IOPS capacity that we're now making available to their environment, what can they use that for? If they've got particularly read-hungry workloads running through their SQL servers or other servers, they don't have to be SQL, that means that they can get more work done in the same amount of time, simply because those workloads aren't having to wait so much on the storage before being able to get on with their next operation. But that additional IOPS headroom means now they can host more machines, more workloads, more users over that same storage infrastructure, and really increase the return on the investment they've made in that storage hardware. They can do more with it now. So in terms of IOs per second that the storage can cope with, this is like saying, here's 61%, Mr. Customer, of a whole new SAN that you didn't have to buy. Now start spinning up more machines and more workloads because you now have the IO capacity to do it. ASL Marketing here in the middle, they were doing SQL batch imports. They were taking 27 hours to complete, which is a long time. And we were able to drop that down to just 12 hours. Now, no additional hardware required. All they did was install our software and allow it to use some of that idle available memory. Last one I pick up here, response times for SQL, their CRM and email are now 90% faster than they were. The common theme here is that we at least doubled the performance for their workloads that they were running, including SQL workloads, with the hardware infrastructure they already owned. And now they can, in some cases, keep that hardware running for longer. And I hate this term, but they can sweat their assets for a greater amount of time. So yeah, all of these are case studies that you can have a look at. And again, more customer examples, and I won't read through every single one of these, but this first one is an interesting one. It's the University of Illinois. Now, they bought an all-flash array, and they were wondering if they still needed our software. So we ran some tests with them, and these are the high-level results. So with our software turned off, 1.5 gigabyte of storage IO traffic took 4 hours to process, and just under 14 million IOs going out to their all-flash array. When they enabled our software, a greater amount of storage IO traffic took significantly less time to process and significantly fewer IOs. You went down from 14 million IOs to just 2.7 million IOs. Now that's important to them because that all-flash array is a very expensive piece of kit. It does not make sense to choke it up with all of this excess unnecessary storage IO traffic that frankly doesn't need to happen. The other one that's interesting here is this Agrium one. They, running SQL databases, they began to slow down, and they were only 3 years into their storage cycle. And when they bought this storage, they had expected to get at least 5 years from it. But 3 years in, it's already starting to go slow. We were able to put our software in for them, and we doubled the performance of their SQL instances, not only to keep them on their current SAN, but it means that they can keep that SAN probably running for longer than 5 years. They're now looking at projecting 6 or 7 years out of that storage infrastructure. So they're very, very pleased with that. So in terms of next steps, there's a couple of options here. firstly, we're going to provide you all with a copy of our software that's fully featured, one full free license that you can put onto a test system, so you can run some tests, you can learn how the software works, see how easy it is to install, see how little there is to configure, and use that dashboard to see just how much of the storage IO traffic we can eliminate, how much storage IO time we can save, and more importantly, what that actually does to the performance of your SQL servers. So we'll provide you with a full copy of that. You should get that in the next day or so after the after the webinar's finished. If for any reason anybody doesn't receive it, sometimes these emails can go out and get caught by a junk mail folder or filtered at a firewall layer. If for any reason you don't get it, feel free to reach out to me directly. My email address is sallingham@condusiv.co. Similarly, if you have any techie questions that you want to go over with me, feel free to reach out and I'll be happy to help. So yeah, you can download the NFR not for retail copy and have a play with that. We also have, if you want to do a larger scale proof of concept, we have 30-day trialware, which will run fully featured for those 30 days. And I would encourage you to install that onto as many machines as you can that are sharing the same storage. That's really where you're going to see the most bang for buck, because now from the point of view of the storage, you're eliminating and optimizing as much of the storage traffic as possible, regardless of which machine's generating it. So now that slower back-end storage is now doing the least amount of work. And there is one other option that some people like to start with, and that's with a free utility called the IO assessment tool. So let me show you this. The reason why a lot of corporate level customers like to start here is that this is completely non-disruptive. It's not going to fix anything and not going to make anything perform better, but what it will do is show you if you have storage performance inefficiencies that are affecting your SQL servers or other machines in your environment. As I say, you don't install anything on any live servers. You don't have to reboot anything. You just install it on one machine that can see those live servers on the network. It then uses Windows Management Instrumentation, or WMI, which is a part of the Windows OS, to grab some of the counters and metrics that would normally get used by things like Windows Performance Monitor or Resource Monitor or Task Manager. And we collect that data, we put it into a simple text CSV file, and then we produce a report like this. And you can see the machines get color-coded, red, yellow, or green, depending on whether they're being critically impacted by storage performance inefficiencies, whether they're being moderately impacted, or whether actually they're running just fine. And then we'll list out the metrics that we've measured, so things like the amount of workload that the storage is having to process, the IO response times, how long is it taking to process those IO requests, is there an IO queue forming? And we'll show you at what time of the day it's better and worse than others. So you then have a conclusion at the end that says, Mr. Customer, your potential for IO performance optimization with a product like Diskkeeper or V-Locity is either high, medium, or low, depending on what we found. And then we'll explain that conclusion with a few bullet points at the end. So this is a really great way of non-disruptively figuring out, do you have storage performance inefficiencies? If you do, what are they? What machines are they occurring on? And at what time of the day? So those are really what I would suggest as the best next step options. If this sounds interesting and you have an appetite to look further, certainly play with the NFR copy that you're all going to receive. That's a full free version for you to keep. Keep in mind we have the 30-day trialware, and we have this assessment tool so that you can see if you have problems that need fixing with the trialware before you really go down that route to save you time. And of course, we're very happy in engineering to engage with you directly and help you run the software, help you interpret the results. Quite often I've been writing recently engineers reports that show exactly what we've been able to do, maybe make recommendations about how to get more performance gain out of the environment. And people have been using that to share internally to say, actually, this is stuff we really need to start looking at, because without it, our SQL is going to continue to run slow. So I think that's probably enough of me talking. So I'm going to ask David to come back in and see if there are any questions. And you guys, if you have any, feel free to put them in the Q&A box or in the chat box, and we'll try and make sure we answer them all. David?
That's great. Thank you very much, Spencer. Okay, let's have a look at any questions that have been asked. And if anybody wants to know anything, ask now.
Well, you know, one of the main questions that I get asked about our technology is it just for Windows, or does it also work with non-Windows operating systems like Linux, for example? The short answer is no, it is just for Windows at the moment. We do have a Linux version on the roadmap, but right now this is for physical and virtual Windows systems running things like SQL, SharePoint, file and print servers, Microsoft Dynamics, that type of thing.
Okay. Well, I think we can take this as a testament to your demonstration and presentation skills, Spencer. No questions at this point. So thanks everyone for attending, and to Spencer for taking us through the solution. If you do have any questions and you'd like a one-to-one demo or pricing or any further information, please either get in touch with me at Grey Matter or Spencer at Condusiv. So you can call or email me. I'll make sure that I reach out to you just to make sure that you have everything you need. You'll be sent a short survey after the webinar to get your thoughts and ideas for future webinars. And so your feedback would be greatly appreciated on that. So thank you very much, everybody. Thank you. Bye-bye.
Cheers. Take care.